Very good morning, good afternoon, good evening, whenever you are watching the videos. Now, in today class, I am going to complete one chapter, and the name of the chapter is called Amines. Today, I will try to dictate this chapter in such a way that you will not find any difficulty. Just see over here the things very properly. Don't try to go outside whenever you are watching the videos. Concentrate for half an hour, max to max 1 hour. I will complete all the things regarding this chapter. Don't worry about this. So just focus over here. In NH3, everyone knows that it is known as ammonia. Now, if you remove one hydrogen, suppose NH3 can be drawn like this, na? Don't get confused. Yes, sir, you have just started the chapter. How could I get confused? This is called ammonia. Now, in this part, suppose you are going to remove one hydrogen and put one alkyl group over here. You know, na? Alkyl group has a general formula CnH2n plus 1. It should be CH3. It should be C2H5. One hydrogen less than alkene. Suppose you are going to remove one hydrogen and put over here one R. So this is known as 1 degree amine. In the same way, suppose you are going to remove one more hydrogen and putting it to alkyl group. So this will become 2 degree amine. And in the same situation, if we are going to remove all the hydrogen and putting 3 alkyl group over here, so it is known as 3 degree amine. And if you suppose you are using the lone pair of the amines also, because amine has one lone pair, in place of that, one R over here, one R over here, one R over here, and one more R you are putting over here, so nitrogen will get one positive charge, and this is known as quaternary ammonium salt. Quaternary ammonium salt. So this is the basic things about amines. What is mean by ammonia? What do you mean by 1 degree amine? What do you mean by 2 degree amine? What do you mean by 3 degree amine? And what do you mean by quaternary ammonium salt? After knowing this part, if you have to take the screenshot, you can take the screenshot of this. Okay. After knowing this part, we know that whenever we are studying any chapter, we are studying the chapter in 3 ways. First, we will know what is the preparation of the name of the topic given. Second one, physical properties, and third one, chemical properties. The first topic we are going to see preparation of amines. That is also known as method of preparation, MOP. That is preparation of amines. First method to prepare amines is from reduction of nitro compound. The first topic for the preparation of amines is the reduction of nitro compounds. Whenever we are going to reduce nitro compounds, and everyone is familiar with what do you mean by reduction of nitro compound, and after completing this chapter, what do you mean by reduction, everyone knows, na? After completing this chapter, I will upload the PDF also on the YouTube. Don't worry. If you don't have to study the video lecture, you can directly see the PDF over there. Now over here we will have H2 plus PD in presence of ETOH. ETOH means C2H5OH. This is also called alcohol. So either you can take this first reagent. If you don't want to take the first reagent, then you can take the second one. In the second reagent, you can take SN in presence of HCl, or you can take the third reagent. In the third reagent, you can take Fe in presence of HCl. So out of the first reagent or second reagent or third reagent, if you take any one of the reagent, then oxygen will be removed and hydrogen will be attached, and this is known as reduction. You know, na? What do you mean by reduction? Reduction means removal of oxygen and addition of hydrogen. So this is known as reduction of nitro compound to aniline, and this is the first method to prepare amines. Aniline is the proper compound coming, but this is the first method to prepare amines. The reduction of nitro compound in presence of H2PD ethanol or SN plus HCl or Fe plus HCl, nitro compound reduced to aniline. This is the first method to prepare. Now, as I have started the preparation over here, so I just want to complete preparation plus chemical properties of aniline also. Means written the heading, but some chemical properties also I am going to cover. Chemical properties of aniline also I am going to cover. Sir, you are making us confused. Don't get confused. What I have started. First I have given you ammonia means NH3. 1 degree amine means 1 alkyl group. 2 degree amine means 2 alkyl group. 3 degree amine means 3 alkyl group. Quaternary ammonium salt means 4 alkyl group. Then I have started preparation of amines. In the preparation of amines, I have told you that reduction of nitro compound is the method to prepare amines, and in that you will have to use the reagent as H2PD ethanol or SnSCl or FeSCl. Then you are able to produce aniline. Now whenever you will take aniline, sir, suppose aniline you have already prepared, you have prepared aniline, I will go with that portion only. Now suppose you are going to react this aniline, this part NH2, this can be also written as PHNH2, means PH means benzene ring NH2. So either you can write with the structure like this, or you can write like this and this, both is known as aniline. Now that aniline will react with NaNO2 plus, suppose HX, X should be chlorine or bromine. Don't try to take iodine, and always try to take low temperature. Low temperature means approximately 0 to 5 degree Celsius, that is also in Kelvin 273 to 278 Kelvin. So if you take aniline at this low temperature, then aniline is going to be converted in benzene diazonium salt. It means the structure will come like this. Benzene ring over here, N triple bond N plus Cl minus. This way the structure will come, or sometime they will write like this, so don't get confused in this. Benzene diazonium salt N2Cl minus, or sometime they will write PH N2Cl minus. PH means benzene ring, that is also known as phenyl. The name of this compound is called benzene diazonium salt. The name of this compound is called benzene diazonium salt. A question arises, does we have to study the mechanism from here to here? So from here to here, mechanism not important. From here to here, mechanism not important. Mechanism is not important from here to here. But if you have to convert aniline to benzene diazonium salt, aniline to benzene diazonium salt, then mechanism is important. Then our mechanism is important. So we will have to know about the mechanism of this part. Okay, sir. So now I am going to change the another PDF, and from where I will start the things. If we will see the mechanism over here, what the mechanism will do? First of all, we will have this reaction mechanism. Mechanism we are going to write. If we are going to write the mechanism, this part you have already taken the screenshot. Now we are going to see over here the mechanism of this reaction. So what we will say, कि sir, in the case of mechanism, what we have taken, sir, we have taken PH NH2 in presence of NaNO2 plus HCl. Suppose I am going to take at the time of mechanism 0 to 5 degrees Celsius, that is 273 Kelvin to 278 Kelvin, that is low temperature. What happens in this part? So it will convert into benzene diazonium salt, N2 plus Cl minus. So what is the mechanism behind this reaction? So we will try to understand the reaction you have already written. Don't get confused. I will give you the PDF also. Now I am going to dictate you the mechanism, so I have side out that portion. Now if you see the mechanism of the reaction that is taking part over here, so what happens? First of all, you will take NaNO2 plus HCl. Now you know this part, in this part it will break as Na plus NO2 minus O. On O it is minus, and over here we will have HCl will break as H plus Cl minus. What it will form? HNO2. This positive will attack with negative, this negative will attack with positive, and you will get HNO2 plus NaCl. HNO2 is known as nitrous acid. Nitric acid is HNO3. It is HNO2, nitrous acid. Now this nitrous acid has a structure something like this. N double bond O, and this side O and H. This is nitrous acid. Now what happens? This nitrous acid we are going to do the protonation over here. So we are going to do the protonation. First of all, we have breakdown NaNO2 plus HCl and forming nitrous acid. Now we are going to do the protonation on nitrous acid. Protonation of nitrous acid. Protonation means attack of H plus. Attack of H plus. So what happens? We will have over here OH and double bond O. It has a lone pair. It has a lone pair. Now if H plus will attack over here, where it will attack? It will attack on the lone pair of electron. Because of attacking on the lone pair of electron, what it will become? OH and double bond O. Now as oxygen has attack, as hydrogen has attack on the lone pair of oxygen, so oxygen will become positive. Now we know that this water is a very good living group. Living group. So water will remove from this, so H2O will go, and we will have NO has 1 plus. So whenever we are studying coordination compound, so whenever they will give you NO compound, so over there we are saying NO compound has 1 plus charge. NO plus you are getting. Now benzene diazonium salt will come, PH NH2. Now it has a lone pair of electron. NO plus is over here. A plus means it wants the electron, so it will try to go on the lone pair of benzene diazonium aniline, nitrogen lone pair. So it will go over here, PH N H H, and on the lone pair this will attack. So this nitrogen to satisfy their valency, but this nitrogen has one more bond, so this nitrogen will get now positive charge. After that what happens? To remove this positive charge, nitrogen will take the electron from hydrogen and going as a positive charge, means hydrogen will remove and the negate positive charge on nitrogen will be gone. So what you will get? PH NH and double bond O. And first you have done protonation over here. First you have done protonation, and in this step you are doing deprotonation. It means addition of hydrogen, and then you have done removal of hydrogen also. Now from here you will do tautomerism. What you will do? Tautomerism. Tautomerism. What is the condition for tautomerism? X, Y, double bond, Z. This Z is most probably OCl, not Cl, sorry. Most probably you will see O, or if you don't want to do it like that, it is considered to be 1, it is 2, it is 3. 2 and 3 has a double bond, tautomerism condition, and first has hydrogen. First X has hydrogen and 2 and 3 has a double bond. So if you see this compound, what you have over here? Hydrogen. This is 1, sorry. This is 1, this is 2, and this 3. First has hydrogen and this has double bond. The double bond from here coming over here. So it will become X double bond Y, single bond Z, and the hydrogen that is attached with X, that will come with Z. Means if you do the tautomerism, what you will get? PH over here N double bond N, and the hydrogen from here going this side. So it is also known as 1, 3 tautomerism. So it will become NOH. Is there any problem up to that? If you have the problem, we will try to discuss the things whenever I will teach you the topic called tautomerism, that is GOC, General Organic Chemistry. After that what happens? This OH minus is again leaving from here. This OH minus is again leaving from here because it is again became a very good living group. Now as it will leave from here, what you will get? PH and double bond N, and double bond N, and OH will go from here. This OH will remove from here, and now this N double bond N, if you see over here properly, so this N has one less lone pair, so it will become positive. This has exact 3 bond, so it will become 1 lone pair. Now at this time, at exact this time, what happens? This nitrogen will share this lone pair over here to justify this positive charge, and because of sharing you will get PH and triple bond N. Now as this nitrogen has given the electron, so it will become positive over here. Now HCl will come. HCl will come. H plus Cl minus. Now this H plus and this OH minus will goes outside as H2O, and you will get over here PH N plus triple bond N and Cl. This can be also written as PH N2 plus Cl minus. So mechanism always I am saying not that much important, but still you want to understood. See over here, first what happens, NaNO2 plus HCl converted into HNO2 NaCl. Then after that we have done the protonation on nitrous acid. This is the nitrous acid. After doing the protonation, it will become OH, H, and as we have already attached H plus. Why we will remove H plus? We will remove H2O. So H2O is a very good remove. We will get NO plus. Now this NO plus is attacking on the lone pair of the aniline. After attacking the lone pair, nitrogen get one more bond, so it will remove the hydrogen. So first over here protonation, then over here deprotonation, then you will come over here. In this step we are using the tautomerism. By the tautomerism it will become this. Now we are taking over here HCl because lots of amount is there of NaNO2 plus HCl. So we are taking HCl again, and over here OH minus will go with HCl, H plus it will become H2O, Cl minus is attacking over here. It means from here what you will say, ki NaNO2 you are using 1 mole, but HCl you are using 2 mole. First mole you are using to convert that into nitrous acid, and second mole you are using over here to convert that into benzene diazonium salt. So I hope you all have understood the mechanism and the method of preparation. So first I have dictated you method of preparation of aniline or amine from nitro compound by reduction, and then we have converted into benzene diazonium salt. And this benzene diazonium salt has a mechanism. This one you will see once. If you are not able to understand, ask me again. But now I am going to write all the possible reaction of benzene diazonium salt to produce different product. Take the screenshot. I will see if you have to take the screenshot, take first this. Taken this screenshot? Okay sir. Now take the screenshot over here. First you will take this part. I will make it one page. Take the screenshot over here. Okay. Yes, now come to all the possible reaction of benzene diazonium salt.